Exercise 4, Advanced Integration Techniques, Partial Fractions, Part 2. Number 1, find the integral of 1 over x squared plus 1 times x squared plus 2 dx. Now just pause the video and have a go at this one. So here are the solutions. Now we have that 1 over x squared plus 1 times x squared plus 2 will be equal to ax plus b over x squared plus 1 plus cx plus d over x squared plus 2. So 1 is identically equal to ax plus b times x squared plus 2 plus cx plus d times x squared plus 1. Removing the brackets, we get ax cubed plus bx squared plus 2ax plus 2b plus cx cubed plus dx squared plus cx plus d. Right, so we can see here, take this one, we can see that a plus c must equal 0. Take this one here now. We can see that b plus d must equal 0. Take this one. And we can see that 2a plus c must equal 0, and finally 2b plus d must equal the 1. Right, so we take, we'll call that equation 1, equation 2, equation 3, and equation 4. Now if I subtract 4 minus 2, I get b equals 1, which implies, of course, if b equals 1, that d equals minus 1. We have also that in 1, that a equals minus c. So we put this back in here, we get minus 2c plus c equals 0, which means that c equals 0, and of course a must equal 0. So both these guys will go out, and we'll get the b was 1 over x squared plus 1 minus 1 over x squared plus 2, and you can see very easily that that simply comes out to the 1. Sometimes you can just write that straight down if you can see it, rather than going through all this. It's not a bad idea to just try that to save all that work. Alright, so now we can write it down that the integral is equal to 1 over x squared plus 1 minus 1 over x squared plus 2 dx. Now these are both inverse tan functions. That's the inverse tan of x minus 1 over, because this is the square root squared, that's the root of 2, tan to minus 1 of x on root 2 plus a constant. Okay, question 2. Find the integral of x cubed over x cubed minus 1 dx. Now be warned, this is a particularly challenging one to do. Lots of parts in it. So just pause the video and have a go. Good luck. Alright, here we go. Now this one here, you can't, because the degrees are both the same, you have to do a manipulation here. So we'll say the integral is equal to, now I'll write this as x cubed minus 1 plus 1 over x cubed minus 1 dx, which is 1 plus 1 over x cubed minus 1 dx. Of course, that will be just simply x plus this integral. So now we'll have to do this one. We'll come back and use that a bit later. So we're going to do another integral. Our I, we'll call it I1, is equal to 1 over x cubed minus 1 dx. And we can factorize that. 1 over x minus 1 times x squared plus x plus 1 dx. Right, now using partial fractions, we can say that 1 over x minus 1 x squared plus x plus 1 is equal to a over x minus 1 plus bx plus c over x squared plus x plus 1. So 1 is identically equal to a into x squared plus x plus 1 plus bx plus c into x minus 1. Removing these brackets, we get ax squared plus ax plus a plus bx squared minus bx plus cx minus c. Now we do some grouping. There's our x squared there. So that's going to be 1 equals a plus b x squared. And we've got it, there's the x's here. So now we'll have plus a minus b plus cx, and we'll have plus a minus c. So a plus b equals 0, equation 1. A minus b plus c equals 0, equation 2. And a minus c is equal to 1, equation 3. So we have that a is equal to c plus 1. So we're going to have, in number 1, we can write that as c plus 1 plus b equals 0, or c plus b equals minus 1. Call it equation 4. Put that one in here. I'm going to have c plus 1 minus b plus c equals 0. So that means that 2c minus b equals negative 1. Equation 5. Okay, adding those two together, we get that 3c equals minus 2. Means that c equals minus 2/3, which of course means that a must equal 1/3, and b must equal minus 1/3. Right, so now we have the integral of 1 over x cubed minus 1 dx equals, taking the third out the front, and we'll have 1 over x minus 1. Now write this as minus x plus a 2 over the x squared plus x plus 1 dx. Alright, continuing on. This part's alright. So it's going to be equal to 1/3 the log of x minus 1. Now this one will be minus 1/3 the integral of x plus 2 over x squared plus x plus 1 dx. So we'll have, taking this part, that's going to be I3, I think it is. It's going to be equal to minus 1/3 outside of. Now I'm going to multiply that one by 2. So that's 2x plus 4. So change that to a 6th over x squared plus x plus 1 dx. And now we'll write this as 2x plus 1 plus 3 over this x squared plus x plus 1 dx. Really got to concentrate now. Now this one is simply minus 1/6 the log of x squared plus x plus 1. Now this one will be, taking the 3 out, minus 1/2 the integral of 1 over x squared plus x plus 1 dx. And of course this equals minus 1/2 integral of 1 over x plus 1/2 all squared, and complete the square, plus 3/4, and 3/4 is √3 on 2 squared. And you see that's the inverse tan. So that's minus 1/2 times, now this will be 1 over this, so it'll be 2 over √3 tan the minus 1 of 2 on √3 x plus 1/2, which is minus 1 on √3 tan to minus 1. Now this becomes 2x plus 1 all on √3. So we're almost there. So we go back to the beginning. We had an x. We had plus 1/3, remember, the log of x minus 1. Here's our minus a 6th the log of x squared plus x plus 1 minus 1 on √3 tan to the minus 1 of 2x plus 1 all on √3.